Example 3 in 3.1 really shows maybe the point of knowing some of this general parabola kind of theory, if we want to call it that, because it can allow us to really determine whether we would expect to have any answers, one answer, or two answers. So this question wants us to determine the number of x-intercepts, not the x-intercepts themselves, for each quadratic function. So what we're going to do here is I'm going to write vertex form again. You'll probably have that memorized before today is out. So y equals a times x minus p squared plus q. And then all we're going to do is we're going to identify the parameters for each question. So in part A, the A parameter is 0.8, the P parameter is 0, there's nothing being added or subtracted to the X, and the Q parameter is -3. Now what this lets me know is the vertex is down here at 0, -3, and because A is positive, the parabola opens up. Now I'd like to draw this sketch to really show, because we would expect to have 1, 2, there will be 2 x-intercepts. Now, there is another thing that I think it's important to write, or sorry, I'm going to write this as well. There are 2 unique x-intercepts. And all I mean by that is because the graph is going at 2 or going through the x-axis in 2 different locations, those will be different x-intercepts. Now, because these parabolas are symmetrical, whatever the value of 2 is, 1 is the negative, because that parabola looks the same on either side. All right, let's do B. We're going to do the same thing throughout. So looking at B, I can identify that the A parameter is +2, the P parameter is +1, and the Q parameter is 0. Now, what that lets me do is I can draw this function. I know that it's the standard parabola, a little bit more narrow because A is +2, but it's been moved 1 unit to the right. So my parabola looks something like this. And the vertex is on the x-axis itself, so there will be 1 x-intercept. There's only one location where this function is equal to 0. And what's kind of nice about vertex form is that equation, or that function, is equal to 0 when x is equal to 1. Because the vertex itself, 1, 0, is when the function is equal to 0. Okay, one more, which is C here. I'm going to try to sneak in the information on the bottom. Maybe I'll just separate this a little bit so we can tell which is which. So C, I'm going to write it at this point. It tells us that the function in terms of x is equal to -3 times x plus 2 squared minus 1. What I'm going to do then is, according to my vertex form, I can identify that A is equal to -3, P is equal to -2, and Q is equal to -1. Now, students struggle with this one, typically for a month, and then it really clicks and it becomes kind of second nature. The reason P is -2 is because I could write, or should write, that f of x is -3 times x minus -2 inside the bracket being squared minus 1. And it's really important to recognize that because of the way vertex form is written, as A times x minus p squared plus q, even if it looks like we're adding a number to x, it's because we're subtracting a negative. And that is frustrating for a lot of students initially, but really when we get to 30-1 and we talk about function transformations in general, it becomes much, much the lesser of two evils, because we can just say that this graph goes p units horizontally. When P is negative, we go to the left. When P is positive, we go to the right. That's really why we make it that kind of rule. So this lets me know that the vertex of this parabola is at -2, -1. And because A is negative, my parabola opens down. Now, another way of looking at this is the maximum value. Let me mark that vertex on there. It's -2, -1. The maximum value of this parabola is when y is equal to -1. So y is never equal to 0. So we would have no x-intercepts. And that is a possibility, and sometimes students find that frustrating about math, is as we work towards advanced math or AP math or calc, whatever it is, we can find that a lot of solutions can have many answers, one answer, or no answers. And I know it seems a little bit cruel perhaps, but sometimes it is a valid solution to say that there are no solutions for a question.